Good morning, folks. Back live. Here's the story today. We are going to do a short stream, just under a couple hours. I got one meeting, and I'm back for a bunch more hours until dinner, and then I'm back in the evening. And then tomorrow I'm here for probably at least 11 hours. Hopefully 12. I want to just completely crush the low-level side today with Puffer. It's quite a lot that goes into that. But we're going to get started and see what we can do. There are some experiments that I have to check on first. Make sure that is progressing well. But yeah. A lot of this stuff's going to be new for me as well. But we're going to figure it out, and it's going to be good. Okay. Well, first of all, this Neptune stuff was a mess. We can just ignore that. Nothing good there. Okay, and then I also have... Let me go grab it. My window go. Emacs. That doesn't look good. No object max cost. Ah, I see. That's annoying. Why did this not get merged correctly? Let's take a couple minutes to fix this first. Hello, Cratch. There's someone who wishes to be as technical as you. Guides on my X here. A good starting point. Like these two guides. Let's figure out what the heck happened here. There is no max cost thing in here at all. How did this get, how'd this get merged? Weird. Okay, let me go grab the other box. Yeah. Morning, Nick. And good morning. If that's two different Nicks, good morning, good morning. Okay. So what to do? Where I left off, I was messing with coup de graphs. I don't know if I want to start messing with coup de graphs again right away. I would like to figure out what it's going to take to make this thing fast. Because then, yeah, there's also BF16. Okay, so there's a fair bit of stuff to figure out with what we're going to do here. Automatic hyperparameter. Yeah, that's what it does. Okay, I guess one thing that we could do is we could figure out how much overhead is coming from this thing. Let's go comment all this graph stuff. And let's go comment this. So we can do star. Okay. We'll see how this goes. Headset as well. Oh, right. There. This should work. Alright, so there's your base SPS. 4 mil. Let's go. And then let's figure this one out. Just do chunks times gate. We're just trying to get like a perf test on this thing. Oops. Why does my stupid LSP not catch this? Okay. So, this gives us upper bound, right? Hang on, this is not getting used. Hidden. Where did you learn CUDA? No. Not book. I just start writing it, I don't know. It's just C. 1.1 mil on 6 pixels. That's funny. Alright, this is upper bound at the moment. So this is a bad upper bound, which should be way faster than this. It should be way faster than this, right? Your audio doubled? Why did nobody friggin' tell me that? How is my audio doubled? What the hell? Hang on. Is it fine or is it broken? Heh. Twitter sucks. Let me see what this network size is. So this is the smallest possible thing, right? Oh, we're gonna figure this shit out. No, we're gonna figure this out. The heck? Hello, Son of Liberty. Today we're really gonna get into some deep perf optims. This is the goal. I'm gonna see what's actually required for 10 millisteps per second, and we're gonna just start hammering at it. And if there's like fundamental stuff in the way, we're gonna tear it apart. Oh, I see. They're called expansion factor. Okay, so this should be the simplest possible thing. Wondering why did you go for pure C instead of C++? I'm doing C++ right now, and this shit is giving me fucking depression. This is awful. This is a terrible language. Everybody who did this stuff should feel terrible about themselves. Like, this is just horrible. This is like the worst possible everything at once. God. Like, literally all the stuff that's in here, that's like all the C++ stuff, exists purely to make my life miserable. It's like, oh yeah, let's just add this feature, and then soon enough, you have no idea what the fuck is going on. You have no idea what things are fast or slow. You have no idea how anything works under the hood. The documentation is non-existent. It's just not a fun time, man. All my dev in PRC is so easy. I can show it to a first-year undergrad and they can read it and understand what's going on. It's just like, you could write the exact same code and it'll run on a GPU as well. There's just no reason for any of this stuff. The heck happened? Yeah, actually, it got to the point where I started doing this because the Python side was actually too hard. Because, like, there are 10 more stupid things strapped onto it in order to avoid the problems that were created by Python itself. YouTube comments do not show up? Uh... Oh, that's weird. The hell? Why do they show up in my chat here? I see them in my chat window, but not in this one? The heck? Hang on, let me fix that. That's very, very weird. Settings, embed in stream. Copy. If you were to convert a whole MMO from Java, it would be easier to just go from Java to C, honestly. Like, C++ is just going to create problems. It wouldn't be easier to write it from scratch if you're trying to match an existing thing. You would still reference the original for all the mechanics. But yes, there would be core systems that would shrink from 10,000 lines of code to like 100. Full rewrites are like generally easiest, but they're also kind of dangerous in the sense that you'll be hunting discrepancies forever. All right, there we go. Now the YouTube chat shows up. Is PufferLib your creation? It's become a community project at this point, but yes. And I still handle most of the core algorithm dev and high perf stuff and whatnot. Latest version is written in C++. Well, if you mean RS3, okay. But then they also have RuneScript and a bunch of other things. But, like, just being written in C... Like, you can make a mess in any language, right? And you're basically guaranteed to have one when you have a big team and an old code base. Like, QK, have you taken a look at like, Neural MMO 3? Like, go in your head, think about how you'd write it, and think about how long the code would be, and then go look at the code. I'm not saying I would do it exactly that way for a much larger project. It would be a little bit more broken up than it is, but nowhere near the amount you'd expect. Oh. Way more than 28. So exactly. So this is why I make this point, right? Like, in my mind, if you have two pieces of code and one is 10% longer than the other, I can't really tell you which is better. But if you have two pieces of code and one is twice as long as the other, pretty damn good chance that the one that's shorter is better. Especially if the one that's shorter is also not using like a ton of library features and stuff and it's just plain simple code, right? If you're using the same set of tools and you're shorter, it's probably better. Do you think it's a good idea to write Torch in C? I mean, actually, CS231N will have you write your own autograd, I guess, in Python, but you can do it just as well in Torch. Kolmogorov is also... That was like a nerd snipe for my whole lab for a while, though, Yassine, because like you can't actually compute that complexity metric. Kolmogorov complexity. Like, it's a metric you can't compute. So, like, nerd snipe, oh, we should optimize for this. It's like, well, you can't compute it, GG. Right? Why would this be screwy? Oh, you know why? I know why. Are you a research scientist? I mean, you could say so, sure. What the heck is MNCs? The multinational corporations. May I ask, what is the work? These in big labs. I mean, research is research, right? Like, at the moment, so what I'm doing here is I do high performance reinforcement learning development. It's a mix of like increasingly low level engineering and algorithmic work, trying to figure out better algorithms, and large scale experimentation, trying to empirically discover which things are better than others. And even like a little bit of UX and community stuff, since this is all open source. Did you measure performance trade-offs? So UK, you can always write C++ that is as fast as C because like you can just write C and C++. So it's going to be a function of like how many of the fancy C++ language features you use that dynamically allocate memory and do like other safety things under the hood without you actually knowing what's going on, right? So like it's easier to make stuff fast in C than in C++ because your default set of tools is just fast and simple. Like, there are not a ton of things that you need to know how they work in order to not use them in a way that is slow. It's just you have your tools, they are fast, you write brain dead simple code, anybody can read it. Sometimes you end up with slightly more code than the C++ version. Usually you don't even end up with more code, and it's just that easy. The only thing I found so far that I really don't like doing in C, like one, when you're obviously just missing libraries for stuff. Yeah, okay. And then two is just built-in string processing. Sucks. But like the vast majority of simulation work is so easy in C. What is limiting 10 million? That's what I'm figuring out today, man. So I'm trying to hit 10 mil at like a pretty conservative number of n's as well. The heck? I see. No, I have 10 mil ends. No, not 10 mil. I have 4K ends. So it would be way easier at 16K. I think I just get 10 mil at 16K. But that's too many. So I'm like perf optimizing. Like this thing is going to just be stupid fast, okay? This thing is going to be stupid fast and it's going to work and we're all going to be happy about it. Hmm. If you want to know actually the the one like pure algorithmic discovery I could think of that would change everything, like would change a lot of the engineering that I'm doing, is if somebody could find a way to do, basically, if you could find a way to do good credit assignment without having to roll out like 64 plus time steps. But nobody has done this to my knowledge. Like, I don't think there is a, I think there fundamentally probably isn't even a good way to do it. In a couple of years, Puffer will just have the field of RL as mature, stable tech that you can use, that is ultra fast, that solves problems out of the box. And I'm probably by then going to be working on like cool applications, hopefully some stuff in material sciences, biological sciences, various other industries, just like throwing this on really hard problems. And a lot of custom simulator work for for domains that need the sims is most likely. Long-term use case is a really fast RL, just like ludicrously powerful engine of discovery. It just makes simulation as a tech way, way, way more useful. You could take a full modern MMO, cut the fat and run the simulations. Yes, you can absolutely run RuneScape at 1,000,000 steps a second. If you mean that. There's no reason you can't. The corners that you would cut would have, like, no meaningful impact on the game. Doom and Puffer? That's fun. I actually have a binding for Doom, man. It runs pretty fast if you set the rendering settings low enough. What the heck is wrong with this? B length. Why is nobody doing that then? Because nobody knows how the fuck to program. The skill issues, man. It's true. I swear nobody believes me. Like when I describe the levels of incompetence I see everywhere, and it's like, okay, you're just being edgy or whatever. And then like people actually start doing RL and seeing the way I do shit with this, and they go, "Oh, he wasn't joking." Ask Spencer. Spencer did this stuff for a year, and then we went to RLC together, and I just walked around the posters with him and said, "Hey, look at that. Why does that one suck?" He goes, "Oh, that's totally messed up, right? Like those experiments are meaningless." Yep, okay, next one. What about this one? Oh, yeah, this one too. You just go down the whole line and you find maybe one that's like semi-reasonable. It really is just like that. Mm-hmm. I mean, that's the funny thing is like when you actually try to build stuff and you don't get like mixed, you don't get other motives like mixed into it, you can kind of just crush things. Unless you live in Europe, and then you can go do nothing. You can go be a middle manager. Or whatever. Okay, so this is missing seek length for some reason. I don't know how that would have happened. Train? Oh, it is in train. The heck? Oh, is it? Hmm. Big fan. It's a really breath of fresh air compared to existing mainstream fields. Welcome. Come build some cool stuff with us. It's all open source. Any way to do neural MMO environment visual rendering other than the website? Been having some trouble. Simply stops after a few percentage. What do you mean after a few percentage? Only the demo button works. I mean, you mean like this? One second. This is the dev build at the moment, so there are a few rough edges. Oops. You mean like this? You can also run it through Torch as well. You can do puffer eval, and then it'll run with more agents. All of our clients, they all work locally and on the website. It's not just web builds. They're all written in C. The agents are usually a little bit smarter in PyTorch as well. Hey Tim. Oh, well, dummy. Very dummy. Right here. What the hell? C++ is such a dumb language, man. Why would it make this shit private? Why would it make anything private? Didn't know PufferLib supported, been working with Neural MMO baselines. If you're working with Neural MMO 2, that is going to be the super old, super slow version. Neural MMO 3 trains at 500,000 steps a second on one GPU. We've trained it on up to 650 billion observations on one box. It's pretty cool. I would definitely check out the third one, because that's the one that's all tied into Puffer and has all the viz and has all the new stuff and is super fast. Look, I tried really hard during my PhD, but I simply could not do as much engineering as I had to get the project to where it needed to be back then. Now it's actually where it needs to be, right? Like, now the eng is actually pretty much on point. So it's actually, like, usably fast. Okay, so this runs. Yeah, so it's still slow, which is interesting. Like, we're bottlenecked by something other than the network completely at this point, right? We have to be. Let's go try the reduce overhead thing in the Python version. And we'll see if it's that. Interesting. Still not fast. Hmm. Tiny little network. Okay, we do have actual profiling here. So this one has learning. A very low percentage. And without compile. Oh, still low. Interesting. Spending as much time in forward. If I put this here. Oops. Just a little thought. I'm not bashing on Europe like ever unless people ask me about AI and stuff. About like the AI policy. For whatever reason, people kept asking about it yesterday. Let's see. 20. Interesting. So this says 7.5. And then it triples, right? 25. Okay, that's about on par. 25 million at eval. So then it's not this thing. Good, because we wouldn't expect it to be. We should compute some stuff, right? Okay. Heck is this? Recommendation. Forward. Post. Cool. No, I'm not going to say, oh, they use Python, so that's like a wrong paper. That would be completely stupid. Now, it does contribute. It's not even just using Python, it's using the worst, slowest possible Python, such that they are running like 1 to 10 million step experiments on environments that I can solve with a vanilla algorithm in 3 seconds. So they're like basically their code is so slow that they're stuck solving problems that do not remotely matter. And then they're like developing new algorithms to solve easy problems better with no testing whatsoever on harder problems because all their stuff is too slow to test on anything harder. So like basically the best thing you can possibly get out of a setup like that is a clever idea that maybe works. But that's like you publish a paper and it's not actually here's something that'll make anything better. It's like here's a clever idea. And most of the clever ideas don't end up actually working on the harder problems. Look, Puffer here, I'm trying to get us to train at 10 million steps per second in our next update, right? That's our target. Many of them are training at hundreds of steps per second. Not thousands, hundreds. At that point, you just can't do anything. You can't do anything. You're training on a potato. May as well be. What do they use to test? They used like a million wrappers on some of like the older libraries with slow M's in the worst possible configuration that's been inherited from 3 generations of traumatized PhD students. I mean, it's truly depressing work. I don't even know how you do it without going insane. It was starting to drive me insane, and then I like started at least building something throughout my PhD. Yeah, exactly. Happens all the time. Hmm. Day per experiment. Lovely. I don't think this is correct either. I'm trying to figure out where all our damn computer's going, basically. Let's think about this way. So right now, train is half the speed of eval, far fewer steps. Total mini batches, right? $16. Okay. 6 times. Oh, that makes sense. Oh. Aha. We're doing it wrong, aren't we? Yes, we are. Be 8 mini batches, right? So no wonder it's slower. Still, our perf target should be higher. Okay. That's 10 mil with a big net. I mean, with a small net, really. That's 10 mil with a small net, I meant to say. Okay, so let's see how much slower it is with this. So all the speed we can possibly recover from just this architecture change. Hello, Autark. Welcome. And I gotta get my bench set in after this. See how 200 feels today. Okay. So we're actually, good thing I checked, right? We're not losing that much at all on this. Right? We're really not losing very much on this. I has a new toy. Do I want to open? Okay, good. I thought this was going to be something sketchy. Heh. Fun. Is this yours? If this is yours, can I convince you to come apply some wizardry over to Puffer? Not Zig, but we're doing, mostly C and, Kuda is the goal here. I'm trying to make this stuff go fast. Be the fastest RL. That's the point. Replace Torch. Yeah, Torch drives me nuts. Can you explain to me why you have to compile the model, if it's already in Zig? I don't want to wrap it back in Pi. I have a Python front end for PufferLib, but we're adding a torch backend that's the torch CPP library for now, and we might change that in the future. So it's pretty much just the case that like the napkin math on what you should be able to get out of small networks is absurdly high, and we're just nowhere near that, and I'm trying to figure out how we can get it. Comp time. Okay, I see. That's CPU. SIMD alignment tiling. You should be able to pre-compute that though, right? I guess in my mind, one of the main reasons I wanted to not do Python is I just hate how all these compile layers are JITs. So you have to wait for your frickin' RL to start up. Like you have this tiny little network that you're gonna train for 30 seconds and it takes 20 seconds to compile. Cool. Have you taken a look at any of the stuff in Puffer here? We are trying to make RL way faster. It's already the fastest out there, but we're trying to get even faster. Taking it? Cool. Yeah, so I mean, in Puffer 3 right now, right, it's optimized Python torch with compile support, and like there's one kernel that we ship custom. What I'm trying to do in Puffer 4 is also have a C++ backend, and we're testing new architectures that are more parallel. We're going to get BF16. But then even once you do all of that, you're just nowhere near the speed that you should be able to get out of these chips, and I'm trying to figure out why. Like, I can't even figure out at this point where the overhead is coming from. Like, this stuff is cool. Another toy? Let me get my bench set in, and then I will look at your toy. Otherwise, I sit here and be lazy all day. That's 205 for 8. Not far off of the previous PB from when I was 20 pounds heavier. Let's see what you've got here. You're really into zig, huh? Cart pole. Yeah, so I believe that you can do cart pole that fast. We can do cart pole that fast as well. Wait, is this environment SPS? You didn't get 120 mil training SPS, right? $100K transitions. Might as well run PPO. What steps per second do you get in PPO? So the core thing I'm trying to figure out is like how fast we can get this to go. Metal without writing assembly. I mean, are you doing this? Wait, is this GPU or not? Because I can get these environment speeds no problem in just C. We have our own cart pole as well in C. Yeah, welcome SPY. Pure CPU, I see. Okay. Yeah, so yeah, that's the tough thing. We definitely need it to be. If you do CPU based, you can get stuff pretty fast on very small nets. But then as soon as you scale the nets at all, you're just screwed. So what I'm doing right now is first of all, we always have a recurrent cell of some type. Our 3.0 is LSTM. We're going to try a MinGru, I think, for 4.0 if I can get it to work properly. It should be able to be much faster. Why am I running out of breath? 205 on bar behind me, just did set of 8. It takes some effort. Each level of this shit, I say. I mean, honestly, man, just like come hang out in the Puffer Discord and stuff, because we're doing all sorts of low-level Optim right now. And it's currently C++ because libtorch is C++. I freaking hate C++. I think Zig is generally, like, fine. I'm not doing my stuff in Zig because it's kind of a niche language with, like, a hobbyist community. And I think it's going to be worse for adoption. But what I would like to have, right, is if I am stuck... Okay, if temporarily even, let's say I'm stuck with libtorch for a bit, I can probably get the actual usage of libtorch to be very, very close to just clean, simple C. And then the same goes for CUDA. And then I just, like, start stripping away all the extra stuff. DABI, FFI, anylang. Yeah, for sure. I mean, you can bind stuff to anything, right? I'm not super attached to Python. We provide the Python binds. And there's always going to have to be, like, some sort of Python implementation for researchers, I think, but, like, it's pretty similar either way. At the moment, I'm just trying to figure out how fast we can get RL to run, right? Eh. You're not going to supersede PufferLib. I caught you here. Faster single environment loops. So faster single environment loops, the problem is you can't get a fast single environment loop to be fast on GPU because the GPU expects batching. Yeah, especially on CPU only, man. You're way, way better off just trying to help us with this stuff. Because I'm pretty sure... Hang on. So this was one of our like more junior contributors who wrote this. We can probably get even faster, would be my guess. How fast is cart pull? So single thread on CPU. $64 million SPS on one core. And that's by one of our less experienced contributors as well. Oh, cool. You were on the Isaac Lab RL hackathon. Yeah. So Isaac definitely needs some help. That thing is slow as hell. The off policy thing, I think, is a mistake. So I did go read if you didn't read it already, go read my why RL failed to bootstrap blog. I'm pretty convinced off pol is just bad at this point. Puffer to Isaac, cool. What's this? Puffer to Isaac. Hey, Puffer. Cool. That's nice. Yeah, man, if you can jam some low level, like, there's a ton of low level to be done around here. Ton of low level to be done. The RL rabbit hole's pretty deep. My guides on X will help. You can try to just make something faster than Puffer if you want. A couple people have. There's also Lucas. But it's really, really difficult to make something that's, like, actually provides the stuff that you want and is also fast, right? Like, there are a couple libraries out there that can do really, really fast stuff, and they just write, like, a 2-layer MLP in CUDA, and it's, like, 32 hidden dim, and okay, sure. But you can't really train anything on that, right? You need, like, at least, like, 100k params, but typically it's going to go higher than that over time. 100k is already tiny. And you need some sort of recurrent cell as well. And ideally the flexibility to try out new architectures as well. So, like, yeah, it's pretty tough. I could totally see a thing, though, where, like, we just have really well-tuned full kernels for each of the network implementations, right? And then you just basically launch one kernel for some of our specialized nets. I could see something like that happening. Like I said, there's tons of low-level dev to just jam around here. Fused, yeah. What are you doing for Fusion, though? It's like, the thing that I know actually is guaranteed to work is just writing one big kernel, right? A lot of the tools for Fusion out there are like, we'll try to fuse, and maybe it'll succeed, and maybe it won't. Epilogue, prologue. That doesn't work for everything, though, right? Like, they have a few specific activations, and you have to do the same activation on everything. This epilogue, prologue thing, I looked into this yesterday, and it was kind of obnoxious in the sense to me that it's just, like, a dramatically more complicated way of just pasting the matmul into, your kernel and using it directly because NVIDIA's Matmul is not open source, right? Are there no, like, just... Come on, somebody has to have, like, an open source competitively benchmarked Matmul, no? Well, one enrolled optimized kernel. Yeah. But, like, here, I'll show you what I'm doing right now. Like, this would be hard to do with epilogues and prologues, right? So this is the mingru layer. And it's pretty simple for, even this would be a little annoying with epilogues, I think. But then, this is how you have to do it for training. So just use cuBLAST, but cuBLAST isn't open, right? So you have to, like, you can get the cuBLAST Matmul, and then you have a separate kernel launch, right? I have to actually be sure that this is the real bottleneck, though. I'm not exactly sure of yet. I don't think what we can figure out from these perf numbers. Graphs and streams. Yeah, I was messing with CUDA graphs yesterday. It's such a pain in the ass. Some part of me thinks, well, if I just get, if I just fuse everything, then I really don't care about CUDA graphs, but... Right? CUDA graphs are, like, so obnoxiously restrictive. The whole no in-place operations thing with the Torch CUDA graphs mess is just so weird. Right? I like in-place operations. Okay, so this tells us something. Oh, 4257. And then let's see if I comment this. Yeah, at this scale it probably is. But it's honestly not clear to me, like, what is the relative overhead of kernel launch for this? What is the relative overhead of weird memory access patterns not tuned for nets this small? It didn't shift that much. About bring your own allocators. Yeah, I like managing my own memory too. That's why I write a bunch of C. Most of our environments that are written in C, we don't do dynamic allocation like at all. Like we make the env, we do all the inits when we make the env, and we delete everything when we close the env, and there's nothing in the middle. Everything's pre-allocated. Yeah, you can add an arena to this as well in like, or was it area? Yeah, you can add one of those in like, I don't know, 20 lines of C. Yeah, the ocean drone stuff. There's gonna be more drone stuff as well. One of the guys that wrote that we're bringing on as an intern for the summer. Technically IC, but it'll be fun. What the heck are we bound by? What problems do you have with strings and C? Strings and C are just a pain to work with. Can you share? No, you don't get equity as intern. It was fun though. RL framework trained on policy in 4090. Yeah. Stuff works surprisingly well. I gotta go pretty soon for one meeting. And I'll be back for the whole rest of the day thereafter. I'm trying to think like what this indicates I should optimize. Okay, I guess one other thing we can think about is the number of batches. So at a size of 32K, I mean, we are doing 400 batches a second is the target. Well, this whole thing is memory bound, though, is the thing I have to keep in mind. So I'm computing off flops. Maybe if I compute off of memory. Hang on. How would I do that? Machine gods are sad. You're already too many layers of abstraction up. How many layers of abstraction up am I, my guy? I'm like looking at writing my own kernels on this thing. So what, like, is raw CUDA too abstract for you? Like, I'm basically right now, I'm timing stuff in Torch to see where the overhead even is, so I know where I can write kernels and shit. All right, you go ahead and implement PPO in this and see how this goes for you, right? Emitted by Zig. Then you can't possibly tell me that it's too high level when you're using the thing that's emitting the low level. I agree that Torch C++ is too high level. I hate it. But I'm working my way down, right? Because I have this existing, we got PufferLib, which is the fastest thing out there. It's like not a toy. And that, like in 3.0, we get between 3 and 5 million steps per second without going to crazy high numbers of M's or doing other bullshit, right? So I'm trying to get to 10 mil in 4.0, and I'm like, it's an incremental process of basically figuring out where the overhead actually is. Because think about this, right? If I were to try to just say, okay, cool, we're just going to write the whole network in a CUDA kernel and launch it or whatever, well, I have some pretty non-trivial networks, right? And then I also have some pretty non-trivial loss functions that all need backwards as well. So, like, what I would love to be able to do is just go grab all of the PyTorch kernels and, like, actually see they're fused and stuff, but that's also kind of hard. So, like, I'm kind of profiling and working backwards for it. Dude, this is not just yapping. This is me trying to figure out what the fuck to do. Like, deving this stuff is not like shoveling gravel. You have to think about it. Just need kernels for the ops. Yeah, okay, but have you ever tried to go, like, actually get the kernels from PyTorch and see what they're doing? It's kind of hard. And a lot of the time, they're just calling into cuBLAS or whatever. I write my own and figure it out. You're fighting quite a bit, though. Like, if you just, for instance, if you go try to beat the PyTorch LSTM kernel, for instance, it's actually kind of hard. Like, they're just some really well-optimized kernels. And, like, I don't necessarily want to just rewrite all the ops in Torch that it already has. I want to minimize all the overhead, though. I'm a noob. Why not build your own kernels? Well, I will build some of my own kernels, but do I want to just go re-implement all the kernels in PyTorch? I kind of just want to get access to existing good kernels and fuse them in a reasonable way without all the other overhead and stuff associated with them. Right, we were gonna do memory bandwidth checks. I'm actually trying to think how I do this. I haven't done this specific thing before. I think you can probably, hang on, I can probably benchmark this thing via memory bandwidth though instead of flops, and that'll give me a better idea. Write out flops. This is all just my method. Well, I mean, Puffer is the least bad thing, I think, at the moment. I'm trying to make it way better. What are you working on? What's PufferLib? So PufferLib is a high-performance reinforcement learning library. In 3.0, we're currently training RL on one GPU at 3 to 5 million steps per second. I'm working on Puffer 4, which has a bunch of science side improvements, some cool visualizations. And the main thing I'm working on is just some low-level perf optimization to see how we make these smaller networks go really, really fast. or need to model more complex M's. Well, you can just use our M's directly, man. Like, our M's are in C. You can just call them. Do you get inspiration from your client? Sometimes, if we get, like, a bunch of requests in one area. Total data over total access. Hmm. I think if I play with this thing, I can probably get a better model. Okay. Cool. I won't learn anything. You will learn stuff because there's a ton to write. So, like, if you want to write a complex M, write a complex M. But don't reinvent literally everything. Like, at least read a couple of our M's, right? We have a lot of the stuff that you'd want correct. Like, the main thing you need to know, right, is, like, some of the techniques we use, plus the way we do our, like, pre-allocated obs actions buffers. What are you trying to do here? At the moment, I'm working on porting our RL training algorithm to C++ and trying out a few different network architectures that should be a little bit more performant and a little easier to parallelize. And I'm generally just trying to get training to be cleanly above 10 million steps per second. Also just measuring a bunch of overhead. I do have a meeting to run to in a bit, though. I want to make a plan for this afternoon, though, so that we know what to do as soon as I'm back, because it's just like a, I don't know, 30, 45-minute meeting. Hi, Puffer looks cool. Thank you. It's kind of weird, though, because, like, how do you think of slime? Slime? Like, this thing? This is, like, it's an old env that we don't know who wrote the original for this, but then David Ha popularized this. I don't know if that's what you're thinking of. Oh. Lime RL. I've never heard of this. Oh, because of course I haven't heard of it. This is for LLMs. I don't really follow LLM RL. PufferLib is like ultra high performance, small networks, tons of different domains, not language though. There's some good stuff from Tsinghua for sure. Terabyte per second. Hmm. Bandwidth. I guess the thing is we really don't know what the linear layer is doing under the hood other than just calling cuBLAS. I do work on small M's. This is Ubuntu, and yeah, because Puffer is everything but LLMs pretty much. Like all these nets are literally running in on one core in your browser for all these demos. And like most of them train in seconds or minutes, and then we have some harder M's that take longer. Generally, we're trying to make RL just be a really stable, mature, plug-and-play thing. And it's kind of like LLMs in that it's a really, really dependent on perf optimization, but the perf optimizations that go into it are really different from those that go into LLMs. I'm kind of at a loss for what we do next with this. Okay, here's one thing we can do. So let's say that we leave it on like this. This is 10 mil, right? No perf drop. Yeah, so I mean, at this size net, it's like completely bound by not actual flops, right? Is what that tells us. So we know there's stuff to optimize. We're gonna have to do some calcs on memory, I think. That's what we'll do next. Because I think that what's happening is I think I have this really high ceiling in mind from flops, but I'm not accounting for memory bandwidth. Okay. Thank you, folks. I'll be back in a bit. I'm going to go to this meeting. We'll do memory calcs after this, and then we'll see how much ceiling there is, how much headroom there is for optimizing. All of Puffer is open source. Thank you for reminding me. Everything's available at puffer.ai. If you want to help me for free, you start the GitHub. If you want to get involved with the development, on Discord here. And then my educational stuff and research reports are all on the X articles as well.